Okay, here is some answers for the review of Investigations 1 through 3 that I gave you on Friday that is due on Monday. So for number 1, it says name the corresponding sides and angles. Basically, all you need to do is to take this rectangle and twist it so that it is the same direction as rectangle ABCD. Okay, so WXYZ needs to be turned. So just do like a little simple trick that I do here. Just create my own rectangle. And I see that this W, when I turn it, now comes over here. So then I just label it. There's W. So then Z is here. Y is here. And X is here. Okay, so that way I'm not going to get confused. So now it's pretty easy to name the corresponding sides and angles. So side AB corresponds with side WX. Okay, and then here are the rest of the corresponding sides and angles. Side AC corresponds with XW. CD corresponds with ZY. BD with YZ. Then on to the angles. Angle A corresponds with angle W. Angle B corresponds with angle X. Angle C corresponds with angle Z. And angle D corresponds with angle Y. Okay, for number 2, to name the corresponding sides and angles. So it's the same kind of thing. What I did was I just redrew this triangle so that it's in the same direction as QRS. So LMN is going to be in the same direction as QRS. So side QR corresponds with LM. Side RS corresponds with MN. Side QS corresponds with LM. And then the same thing with angles. Angle Q corresponds with angle L. Angle R corresponds with angle M. Angle S corresponds with angle N. Okay, for number 3, using a 2-band stretcher to create a similar figure. For part A, the side lengths will be enlarged by a factor of 2. Please take note of the vocabulary that we are using here. Enlarged by a factor of 2. Do not say bigger or something to that effect, because you need to make sure that you are detailed with your answer. Enlarged by a factor of 2. You can say that the side lengths might be bigger by a factor of 2, but the whole key point is use the word factor. That's what we've been learning about for the past 3 weeks, and so we need to see that vocabulary on the test. B, enlarged by a factor of 2. And for C, the area is going to be enlarged by a factor of 4. Because remember, for area, we're going to have to square the scale factor. Number 4, if you multiply all the dimensions of a shape by the same number, we call this the scale factor. Okay, for number 5, if you use the rule 0.5x, 0.5y to transform Mug into a new figure, how would the angles of the new figure compare to Mug's angles? And the answer is that the angles would remain the same. Remember, when you're multiplying x and y by the same number, the angles will remain the same. If this was not the same number, then the angles definitely would be different. But since x and y are multiplied by the same number, the angles would remain the same. Okay, number 6. How would the side lengths of the new figure compare to Mug's side lengths using the rule number 5? So if you use the rule number 5, which is 0.5 x, 0.5 y, the side lengths would be 50% of the original figure. And you can say this in many different ways. The side lengths would be half of the original figure. You can say 0.5. So as long as we understand that you understand that the side lengths are going to be half or be 50% of the original figure. Okay, for number 7, if you use the rule 4x plus 2, 4y minus 5 to transform Mug into a new figure, how would the angles of the new figure compare to Mug's angles? Okay. Notice that, just look at what the x and y are multiplied by. It's multiplied by the same number. It doesn't matter how much they add or subtract. They're multiplied by the same number, so that means that the angles are going to remain the same. Using the rule in number 7, how would the side lengths of the new figure compare to Mug's sides? The new figure's side lengths would increase by a factor of 4, and you can tell that because x and y are multiplied by 4. So that means that the side lengths would increase by a factor of 4. Okay, number 9 says, using the rule in number 7, how would the location of the new figure compare to Mug's location? The location of the new figure would move 2 units to the right and 5 units down. And the way that you know this is it says plus 2, so that means that it's going to move 2 units to the right, minus 5 means it's going to move 5 units down. Okay, for number 10, it says the figures below are similar. Find the missing side length of x and show all your work. So, when we're looking at this and we make sure that it's similar, which it says right here, it's similar parallelograms. So, what we do is we take this 4.5 meters, we divide it by 3 meters, which I did here. That gives us an answer of 1.5. So that means that the scale factor must be 1.5. So since the scale factor is 1.5, we apply that to this side length down here of 6 meters. So we take the 6 meters and then we multiply it by the scale factor, which is 1.5, and that equals 9. So that means that this side x must equal 9 meters. Number 11. What happens to a figure on a coordinate grid when you add to the x-coordinate? The figure moves to the right. The figure moves to the right. So when you subtract from the x-coordinate, the figure moves to the left. For number 12, what happens to a figure on a coordinate grid when you add to the y-coordinate? The figure moves up. And when you subtract from the y-coordinate, the figure moves down. Okay, for number 13, a shape is drawn on a coordinate grid using the rule xy. What rule would make the line segment of the figure 3 times as long as the line segment of the original figure and moved 5 units to the right and 4 units down? So that means that for rule xy, I would say since the figure is 3 times as long, that means I multiply x times 3. And if it's 5 units to the right, I add 5. And it doesn't say anything about getting higher, so I just leave y the way it is. And it needs to move 4 units down, so minus 4. Okay, number 14. If the rule 2x, 3y was applied to the coordinates of a figure to make a new figure, would the two figures be similar? And the answer is no. No, they would not be similar. And how do I know this? Because x and y are multiplied by different numbers. X is multiplied by 2, y is multiplied by 3, so therefore the two figures would not be similar. Okay, so for number 15, you're supposed to use the shapes at the top, the similar triangles, to answer questions 15 through 19. Okay, so what I did was I just redrew this triangle here to make it be the same, to point in the same direction as DEF. So I made ABC over here. That way I won't get confused. So 15 says, what is the scale factor from triangle DEF to triangle ABC? So I'm going to take the side length of DF, and that corresponds to the side length of BC. So 12 divided by 3, which is over here, equals 4. So that means that the scale factor is 4. Now, going the other way, number 16 asks us what the scale factor is from triangle ABC to triangle DEF. So now we're going to go backwards. So if the scale factor is 4, going from DEF to ABC, that means going the other way, it's going to be 1/4, because you have to divide by 4. So if you're going to multiply by 4 here, you're going to have to divide by 4 to go back here. Alright, number 17 asks, how does the perimeter of triangle ABC compare to the perimeter of triangle DEF? So the perimeter of triangle ABC will increase by a factor of 4, because we found that the scale factor is 4, to equal the perimeter of triangle DEF. Now for 18 is asking how does the area compare? And as we have learned in our lessons, that you need to square the scale factor in order to find area. So the 4 squared is going to be 16. So the area of triangle ABC increases by a factor of 16 to equal the area of triangle DEF. Okay, for number 19, if we had to write one rule for the following to happen to the figure. So if I want something that's 5 times as tall, move to the right 3 units, move up 2 units. That means I'm going to do x plus 3 to move to the right. I'm going to make the figure 5 times as tall, so I'm going to multiply 5 times y, then move 2 units up. That's plus 2. So x plus 3, comma 5y plus 2. Okay, so for number 20, 21, and 22, we're using the 3 triangles here at the top, and we're going to assume that the triangles are similar. Find the missing measurements. So for side B, the measurement's going to be 2 centimeters, because if you take this 10 centimeters, divide it by 5, you're going to get 2. So we know there's a scale factor of 2 between A and B. So then 1 times 2 will give you the side length B, 2 centimeters. Okay, for the side C, it is 15 centimeters, and that is because you take this 3 centimeters, divide it by 1, that's going to equal 3, so we know the scale factor between A and C is 3. And so, since they're similar, this side length and this side length are going to be the same. This side length and this side length will also be the same. So we just simply multiply 5 times 3, and we're going to get 15. And so that's the side length of C. Alright, for number 22, it's talking about what is the scale factor from triangle C to triangle A. So since we know in this direction the scale factor is 3, that means going back this way, it must be 1/3, 1 over 3. Number 23, what is the relationship between the area of triangle A and triangle B? Since the scale factor is 2, to find the scale factor for the area, we must square the 2. So that means that the scale factor area is going to equal 4. Okay, number 24. If you copy an original copy at 150%, what would happen to the side lengths of the image? It would increase by 1.5. The perimeter of the image, that would increase by 1.5. The area of the image now would increase by 3 because you have to take the square of 1.5. And the angle would stay the same. Number 25. If a scale factor of 4 was used to enlarge an original rectangle's perimeter, what would the new perimeter be if the original's perimeter was 5? So if the original perimeter was 5, and we had a scale factor of 4, and we're just talking about perimeter, it's simply 5 times 4, which equals 20, and that would be the new perimeter. Good luck on your test, and I'll see you on Monday.